Hello, and welcome to the Bot Nirvana podcast, where we dive into all things digital automation. I'm your host, Nandan Mullakara. While I'm not podcasting, I help people keep up with the fast-changing digital technologies at botnirvana.org. I hope you enjoy the show. Let's get right into it. Today, we are exploring the future of optical character recognition, or OCR 2.0. It's powered by the new 580 million parameter AI model called GOT. This cutting-edge model is breaking benchmarks, offering near-flawless reading of various formats. This episode itself was generated using Google Notebook's LLM AI, drawing insights from the paper General OCR Theory towards OCR 2.0 via an unified end-to-end model. Let's dive into the future of OCR.
All right, so we're diving into the future of OCR today.
Really interesting stuff.
Yeah, and you know how sometimes you just scan a document, you just want the text, you don't really think twice about it.
Right.
But this paper, General OCR Theory towards OCR 2.0 via a unified end-to-end model.
Catchy title.
I know, right? But it's not just the title. They're proposing this whole new way of thinking about OCR.
OCR 2.0, as they call it.
Exactly. It's not just about text anymore.
Yeah, it's really about understanding any kind of visual information like humans do.
So much bigger.
It's a really ambitious goal.
Okay, so before we get ahead of ourselves, let's back up for a second.
Okay.
How does traditional OCR even work? Like when you and I scan a document, what's actually going on?
Well, it's kind of like, imagine an assembly line, right? First, the system has to figure out where on the page the actual text is.
Find it.
Right. Isolate it. Then it crops those bits out.
Okay.
And then it tries to recognize the individual letters and words.
So it's like a multi-step.
Yeah, it's a whole process.
And we've all been there, right? When one of those steps goes wrong.
Oh, tell me about it.
And you get that OCR output that's just
Gibberish. Total gibberish.
the worst. And the paper really digs into this. They're saying that whole assembly line approach, it's not just prone to errors, it's just clunky.
Yeah, very inefficient.
Like different fonts can throw it off.
And right.
Different languages, forget it.
Oh, yeah. If it's not basic printed text,
Yeah.
OCR 1.0 really struggles.
It's like it doesn't understand the context.
Yeah, exactly. It's treating information like it's just a bunch of isolated letters instead of seeing the bigger picture, the relationships between them.
It doesn't get the human element of it.
It's missing that human touch, that understanding of how we visually organize information.
And that's a problem.
A big one, especially now when we're just like drowning in visual information everywhere you look.
It's true. We need something way more powerful than what we have now.
We need a serious upgrade.
Enter OCR 2.0.
That's what they're proposing, yeah.
So what's the magic formula? What makes it so different from what we're used to?
Well, the paper lays out three main principles for OCR 2.0.
Okay.
First, it has to be end-to-end. It needs to be
End-to-end.
low cost, accessible,
Got it.
and most importantly, it needs to be versatile.
Versatile, that's a good one. So, okay, let's break it down end-to-end. Does that mean ditching that whole assembly line thing we were talking about?
Exactly, yeah. Instead of all those separate steps, OCR 2.0, they're saying it should be one unified model.
Okay.
One model that can handle the entire process.
So much simpler.
And much more efficient.
Okay, that makes sense.
And easier to use, which is key.
And then low cost, I mean.
Oh, absolutely.
That's got to be a priority.
We want this to be accessible to everyone, not just,
Right, not just companies with tons of resources.
Exactly. And the researchers were really clever about this.
Yeah.
They actually chose to use a smaller, more efficient language model.
Oh, really?
Yeah, they called it Quen. And
Instead of like one of the massive ones that's been in the news.
exactly. And they proved that you don't need this giant energy-guzzling model to get really impressive results with OCR.
So efficient and powerful. I like it.
That's the goal.
But versatile, that's the part that always gets me thinking because,
It's where things get really interesting.
yeah, we're not even just talking about recognizing text anymore.
No, it's about recognizing any kind of
visual information
that humans create, right?
Yeah.
Like, think about it. Math formulas, diagrams, even something like sheet music.
Hold on, sheet music, like actually reading music.
Yeah. And it's a really good example of how different this is.
Okay.
Because music, it's not just about recognizing the notes themselves.
Right.
It's about understanding the timing, the rhythm,
It's a language.
how those symbols all relate to each other. It's a whole system.
That's wild. Okay, so how do they even begin to teach a machine to do that?
Well, they got really creative with the training data.
Okay.
Instead of just feeding it like raw text and images, they built these data engines to teach GRT different visual languages.
Data engines, that sounds intense.
Yeah, it's basically like, imagine for the sheet music, they used, let me see, it's called Humdrum Kern.
Okay.
And essentially what that does is it turns musical notation into code.
Oh, interesting.
So GRT learned to connect those visual symbols to their actual musical meaning.
So it's learning the language.
Exactly.
That's incredible, but sheet music's just one example, right? What other kind of crazy stuff did they throw at this thing?
Oh, they really tried everything. Math formulas, those are always fun.
I bet.
Molecular formula, even simple geometric shapes, squares and circles.
Really?
Yeah, they used all sorts of tricks to represent these visual elements as code.
So GOT could understand it?
Exactly. Like for the math formulas, they used a language called LaTeX. Have you heard of that one?
Yeah. That's how a lot of scientists and mathematicians, they use that to write equations.
Exactly. It's how they write it so computers can understand it.
It's like the code of math.
Exactly. And so by training GOT on LaTeX, they weren't just teaching it to recognize what a formula looks like.
Right.
They were teaching it the underlying structure, like the grammar of math itself.
Okay, now that is really cool.
Yeah, and they found that GOT could actually generalize this knowledge. It could even recognize elements of formulas that it had never seen before.
No way.
It was like it was starting to understand the language of math, which is pretty incredible when you think about it.
Yeah. That's wild. Okay, so we've got this model. It can recognize text. It can recognize all these other complex visual languages.
We're getting somewhere.
But how does it actually perform? Like, does it actually live up to the hype?
So this is it, huh? We've got this super OCR model that's been trained on everything but the kitchen sink. Time to put it to the test.
We ran it through the ringer, yeah.
What did they even start with?
Well, the classics, right? Plain document OCR, PDFs, articles, that kind of thing.
Basic, but important.
Exactly. And they tested it in both English and Chinese just to see how well-rounded it was.
And drumroll, how'd it do?
Crushed it.
Yeah.
Absolutely crushed it.
No way.
State-of-the-art performance on all the standard document OCR benchmarks.
That's amazing.
Oh, and here's the really interesting part. It actually outperformed some much larger, more complex models in their tests. So it's efficient and it's powerful. That's a winning combo.
Exactly. It shows you don't always have to go bigger to get better results.
Okay, that's awesome. But what about like real world stuff? You know, the messy stuff.
Oh, they thought of that.
Like trying to read a sign with a weird font or like a crumpled up napkin with handwriting on it.
Yep, all that. They have these data sets specifically designed to trip up OCR systems with blurry images, weird angles, different lighting.
The stuff nightmares are made of.
Right, and GOT handled it all like a champ. It was really impressive.
Okay, so this isn't just some theoretical thing. It actually works.
It's the real deal.
I'm sold. But there was another thing they mentioned, something about formatted document OCR. What is that exactly?
That's where things get really elegant. See, format documents, it's not just about recognizing the words.
Right.
It's about understanding the structure of a document.
Okay, like the headings and bullet points?
Exactly. Tables, the whole 9 yards. It's about preserving the way information is organized.
So it's like, imagine being able to convert a complex PDF into a perfectly formatted Word doc automatically.
Precisely. That's the dream, right?
I would save me so many hours of my life.
Oh, tell me about it. No more reformatting everything manually.
Did it actually manage to do that?
It did, and it wasn't just a fluke. The researchers found that GOT was consistently able to preserve document structure, which really shows that this OCR 2.0 approach, it can understand information hierarchy in a way that we just haven't seen before.
That's a game changer. Okay, before I forget, we got to talk about that fine-grained OCR thing they mentioned.
Yes, that's where it gets really precise.
It sounds like you have microscopic control over the text. Like,
You're telling it exactly what to read.
yeah.
It's like having a laser pointer for text.
Yeah.
You can say, read the text in that green box over there, or read the text between these coordinates on the image.
That is wild. And how accurate is it when you get that specific?
It was surprisingly accurate, even at that level of granularity.
That's amazing. And they didn't even have to, like, specifically train it for every little thing.
Well, that's this part. They actually found that GOT could sometimes recognize text in languages they hadn't even trained it on.
What? Are you serious?
Yeah. It's because, it had encountered similar characters in different contexts, so it was able to kind of, like, make educated guesses.
So it's learning. It's actually learning.
Exactly. It's not just pattern matching anymore. It's actually generalizing its knowledge.
Okay, so big picture here.
Yeah.
Is OCR 2.0 the real deal, or is this just hype?
I think the results speak for themselves. This isn't just like a minor upgrade.
Right.
This is a fundamental shift in how we think about extracting meaning from images. JOT proves that this OCR 2.0 approach, it's not just a pipe dream, it has incredible potential to change everything.
Yeah, it really feels like we're moving beyond just like digitizing stuff. It's like
Yeah.
machines are actually starting to understand what they're seeing.
Exactly. It's a whole new era of human-computer interaction.
And if JOT can already handle sheet music and geometric shapes and complex document formatting, I mean, the possibilities it's kind of mind-blowing.
It really makes you wonder what other fields are on the verge of their own 2.0 transformations.
That's a great question, one to ponder. But for now, this has been an incredible deep dive into the future of OCR. Thanks for joining me. And until next time, keep those minds curious.
Thank you for joining the Bot Nirvana podcast. Appreciate if you can leave a review on iTunes or wherever you're consuming your podcast. Catch the show notes on botnirvana.org. While you are there, feel free to explore more free digital automation resources and more. See you next time.